Are you wondering how to answer some of the hardest math problems on the SAT? In this video, I'm going to cover 5 of the hardest math problems that are covered in College Board's Bluebook exams, and I'll show you exactly how I answer them. So if you're wondering how to improve your skills and answer some of these hardest problems, which are definitely going to be fair game on the SAT. Also, by the way, I got a 780 on the math portion of the SAT on the exam in March, so I know what I'm talking about. I've seen many of these problem types on the SAT while I've been taking it. Then you're going to want to watch this video. Okay, let's read the problem. The table shows 3 values of x and their corresponding values of g of x, where g of x equals the function of x divided by x plus 3, and f is the linear function. Was the y-intercept of the graph of y equals f of x in the xy plane? So first we need to decide what f of x is. It says it's linear, so that means that f of x is going to be in this form, where a is the slope and b is the y-intercept. We're looking for the y-intercept, so we want to solve for b. So let's plug that in the equation for g of x. And now we can use some of the values given in this table in order to solve. So we have 27a plus b negative 24 equals 3, and negative 9a plus b divided by negative 6 equals 0. And you can multiply both sides by negative 6 here. You still get 0. Multiply both sides by negative 24, and you get negative 72. Let's plug this into our Desmos graphing calculator and say that a equals x and b equals y. Alright, let's plug those equations in there. 27x plus y equals negative 72. And negative 9x plus y equals 0. You have 436, okay? All right, 436. And as I said, y value of b is what we're looking to get, so that means that 36 must be b. And if you check the answer here, whoops, A, perfect, we circled A. So let's read the passage. For an electric field passing through a flat surface perpendicular to it, the electric flux of the field through the surface is the product of the electric field's strength and the area of the surface. So flux equals strength times area. A certain flat surface consists of 2 adjacent squares, where the side length in meters of the larger square 3 times the side length in meters of the smaller square. So we'll say that's y. We'll say that's x, and we know that 3x equals y. An electric field with a strength of 29 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volts, what is the electric flux in volts times meters of the electric field through the larger square? So the flux is 4,640 equals strength 29 times A. And you want to get, so the area is going to be each, because the area of square is length of the side squared, it's going to be y squared plus x squared, but you want to get all of the equation into one variable. So you're going to substitute this equation in for x. So what it's going to end up being is 4,640 equals 29 times y squared, and if you move that over, y equals x divided by 3, x equals y divided by 3, and so y squared divided by 9. And so let's calculate. That's going to be 4,640 equals 29 times 10 y squared divided by 9. Okay, and let's see what Desmos has to say that y squared would be. plug that in. 4,640 equals 290. Just multiply that out really quickly. Squared by 9. 12 and negative 12. So length y equals 12. So in order to calculate the total electrical flux of the large square, first you're going to want to create a percentage or proportion of the information you already know. So you know what the total area of the squares combined is because we have the side lengths that we've calculated here now. So that's 12 squared plus 4 squared. And you can calculate what percentage of the total area that the large square holds by putting that in the numerator and dividing it by the total area. And so that's going to give you the percentage of the total area of both squares put together that the large square holds. And all you have to do is multiply that by the electrical flux of the total, which is 4,640, in order to figure out what portion of the flux that the large square holds. So let's put that into Desmos and see what it spits out at us. It's 144 divided by 160, just calculating in my head here, times 4,640 is 4,176. So let's go back and see if we're right here. 4,176. What happens if we switch over? Yes, 4,176. I got a hidden line there. There we go. So it's the right answer. Let's first read the problem. In the given system of equations, a is a constant. The graph of the equations in the given system intersects exactly one point, x, y. In the xy plane, what is the value of x? Okay. So first you're going to want to be able to solve for the variables in this problem. In order to do that, you're going to go ahead and set two equations equal to each other. 2x squared minus 21, x plus 64 equals y, and then y equals 3x plus a. So you can just simplify, say that. And you can also say 4x plus 4 minus a equals 0. Set it all equals 0. And so if you have a typical form quadratic equation, it's going to take the form ax squared plus bx plus c. And in order to solve that equation, you're going to use the equation negative b, or at least in order to solve for x when equals 0. Let me erase some of that there. Squared 4ac 2a. So let's solve for that equation. But the problem is that this equation will give you two values of x, a plus and a minus version. And so in order to only get one value of x, you're going to have to find a place where this part equals 0. So you want the square root of b squared minus 4ac to be equal to 0. So essentially, you just want b squared minus 4ac to be equal to 0. So you can plug those parts in the problem knowing that 2 is a, negative 24 is b, and 64 minus a is c. So 24, or negative 24 squared, square root, minus 4 times a times c, which is going to be that, times 64 minus a equals 0. Let's plug that into Desmos to see what a equals. Okay, plugging that in now. 24 squared, as I said before, you can really take the square root out of there because it's going to equal 0 whether you have the square root or not. It's x, substitute x in for a. Then you have negative 8. Now that you have the value of a, you can plug that back into the original equation. So a is going to be negative 8, so let's plug that in Desmos and find what the value of x is. All right, let's plug that back in. 2x squared minus 21x plus 64 followed by our other equation, which is 3x plus a, which we know is negative 8, 6/10. So the value of x is 6. And let's pull this back and see if we're correct. C, 6. Yes. Okay, the fourth SAT problem from the math section on Bluebook that I found to be one of the hardest. Let's read and draw a picture. In the xy plane, a circle has center C with coordinates h, k. Points A and B lie on the circle. Point A has coordinates of h plus 1, k plus 102. So let's start off by drawing a circle here. Center C, coordinates hk. Oops, there we go. Points A and B lie in the circle. Point A has a coordinate of h plus 1. So wait, no, maybe it's going to be somewhere up here. This is A, and h plus 1, k plus 102. ACB is a right angle. So that means wherever B is, it's going to create a right angle. So approximately something like that. B. And so what is the length of AB? So you want to find this length. So you're going to be using your Pythagorean theorem in order to do this. But you're going to have to create two triangles. Because h plus 1, k plus square root 102 are the coordinates for A, you know that this length here is going to be 1. And this length here is going to be 102. Then you can find the length of the radius because a squared plus b squared equals c squared. So that means that AC is going to be equal to square root of 103. And because the radius across the whole circle are all going to be the same, you know that BC is also going to be the square root of 103. So again, you can perform the Pythagorean theorem and knowing that a squared plus b squared, so 103 plus 103, meaning square root of 2 or 6, is going to be the length of AB. And so now you can compare to the answer choices. And obviously, there's only one answer choice over here that matches our answer. That's A. So let's check. There we go. We got it right. The fifth and final problem from this video on the hardest SAT problems in the Bluebook practice exams that College Board has currently published. So let's read the problem. In the given equation, p is a positive constant. The sum of the solutions to the equation is 20 divided by 3. What is the value of p? So the important thing to note about the parts of this equation is that all of the separate parts are going to need to be set equal to 0. Because if any of them equals 0, then the whole equation is going to be equal to 0. So it's basically, you're going to create equations like this. So let's go ahead and separate those out and solve each of them separately. Let's take the middle one. And solve. So in this equation, you can see that the solutions are going to be x equals 3 and x equals negative 3. You know, all the solutions in total are going to add up to 23rds, but when you add these together, you see that the answer is 0. So, in fact, this middle part of the original equation doesn't have any effect on the answer. Let's erase this and try the first part of the equation. Set 3x plus p equal to 0. And let's solve for x because we're wanting to try to find what the value of x is. X equals negative p divided by 3. So that's going to be our solution for x. Let's go ahead and put that in the corner, and then we'll solve for the other problem. So in order to do this, you're going to use the quadratic equation, which states that negative b plus or minus square root of b squared minus 4ac divided by 2a is what x is going to be equal to if you set this whole problem equal to 0. So let's solve using that vector. So b is going to be 16, and that follows this equation up here, where those are all the constants. So you're going to have positive 16 plus or minus the square root of 16 squared minus 48p, yeah, divided by 4. So that means you're going to have 4 plus or minus square root of 16 squared So you're going to add each of these solutions together. And ultimately, as you can see, this part of the problem cancels out. So you just have 8. So you know that 8 minus p divided by 3 equals 20 thirds. So now you can solve for p. So 8 equals 24 thirds. So you're going to have negative p 3 equals negative 4 thirds, which makes it obvious that p is going to be 4. Now let's see if we were correct. 4. Perfect. Thank you for watching. I hope you found the step-by-step on how to solve 5 of the hardest problems that you'll see on the SAT math section helpful. If you enjoyed it, then please like and subscribe. If you would like another video about 5 more problems, then please let me know. And of course, if there are any problems, whether reading and writing or math, that you want me to do a video on, please leave a comment about it below. Again, thank you for watching.